How much time I have? So you guys have to pay 100% attention because we're going to talk about auto identity. Joshua told me, says Kench did not talk about auto identity thoroughly, so we're gonna make sure we cover that. Uh, honestly, my people might think like I don't like Kench or Ollie. I like them. They're good. They're putting a lot of effort on that too. So um, but I do want to go back to modify their teaching because they don't have as much experience as I do. So let's start with this one. Okay, so we're gonna start uh, with the angle and degree. So should be pretty easy. We're gonna go to like very fast. Just make sure everybody on the same track. You can get more copy. The more copy is in the back because this is a half of the test. You have to memorize all the formula. You have to understand all the formula derivation. Most of my students should remember this. If you're not my student, that's why I'm gonna go over with either with a Kench or Ollie's student. I just want to make sure you understand certain way. A lot of people can go on a TikTok or YouTube short to figure out a shortcut for unit circle, but it's not understanding unit circle. Nicole's laughing. Did you look up TikTok how to memorize unit circle? No? Okay. I thought you did because you're laughing. Anyway, so what we're gonna do is we're gonna import this to the notability so it's easier for me to write. Okay, let's talk about identities first then. We're not gonna talk about unit circle. Identity, you should know sine is equal to 1 over cosine. Okay, sine equal to 1 over cosine. Cosine is 1 over sec. Oh, sorry. I'm so sorry. This is not 1 over cosine. My bad. A 1 over cosecant. 1 over secant. 1 over cotangent. This is 1 over sine. 1 over cosine. 1 over tangent. At a minimum, whether you are in Kench or all these classes, you should know all the reciprocal identity. The only people I don't know is Rohan. Did you remember this? Okay. Now, Rohan, the only thing I will tell you is if you did a virtual school, hopefully you did not cheat. If you cheat, doesn't help you. It's actually going to harm you. The things about virtual school, it can actually do a fairly good job, long as students don't cheat, because you can pretty much cheat your way out through the algebra 1, algebra 2, geometry, and pre-calc. You don't have to spend any effort. Just kind of type in the ChatGPT and tell you the answer. Or Mathway. But hopefully you didn't do that because Nathan did not do that and he does a pretty good job. Tangent data is equal to sine data over cosine data. And this is a cosine data over sine data. Do you have this memorized? Yes? Okay, Gabriela says yes. Okay, Ignacio says yes. And this is just a memorizing. If you memorize to this part, rest of the part we're gonna build it. We're gonna build each equation, how it is. So we're gonna start with the geometry. So in geometry, we got a right triangle. And this is we're gonna have a data. And we're gonna call this A, this is B, this is C. Now this is not a Pythagorean identity in the trigonometry, but we're gonna start with geometry. So we're gonna start with the A squared plus B squared equal to C squared. We should know all the Pythagorean identities. And then second thing is, hey, I can decide to divide it by A squared, B squared, C squared, or by C squared. So I'm gonna take this and I'm gonna divide it by C squared. And that's gonna be A over C squared plus B over C squared. That's equal to 1 because C squared over C squared, that's 1. Can somebody open that door? Charlotte? Oh yeah. Sure. So why is that important? Because that's coming up the first identity. If you think about A is actually opposite of the angle. So usually you see this is opposite, this is opposite. So opposite of the angle. This is also known as adjacent to the angle. And this is a hypotenuse to an angle. So adjacent over hypotenuse. So I can say it right down. This is opposite over hypotenuse square plus adjacent over hypotenuse square is equal to 1. Does that make sense? And what's opposite over hypotenuse? Sine theta. So it would be sine theta square. Now it's like this though, plus cosine square. No, cosine theta square equal to 1. Now, usually if you write like sine theta square, it's more appropriate to write like this because that's easier to understand. So usually I write as cosine square theta is equal to 1. Now on a quiz, a lot of people have tendencies ignore write down the data. Just say, they say sine square plus cosine square equal to 1. Last year on the quiz, I marked it wrong just because I think that's not, it doesn't have an argument. It's like natural log. If I just type in, let's say sine here, right? If I just type in sine here, and without an argument, I press enter, it's gonna show up the exclamation mark. So you have to have an argument. So you have to have a data there. So this is the way to think about this. So you have to have a data there. So that becomes the first identity of Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. Am I going too fast? Okay, okay. So now I'm going to go to the second one. There was the other two. I want to says if you want to prove it, you're going to take this identity and you have to divide it by some easy one, which is divided by sine squared theta, divided by sine squared theta, divided by sine squared theta. Now I usually don't write sideways, but this case I need to because I don't have rooms, plus cotangent of square root theta equal to cosecant square root theta. Does that make sense? Because sine over sine is 1, cosine over sine is cotan, and 1 over sine is cosecant. If you have a question, just raise your hand. There's no dumb questions. I never will question any questions. I'll always answer them. Yes.
Test on Tuesday, are you going to want us to do the a squared plus b squared equals c squared and then the transition into
That part, no. I can basically just memorize sine squared theta plus cosine squared theta equal to 1 because everybody should be allowed to memorize that. And the proving of that one is actually just understand where the word origin come from. Like yesterday, I was teaching a group of 7th grade students. I should show them how quadratic formula comes from. No longer a teacher teach that. I actually teach you how to derive, and I teach the little kids and like how to build a structure correctly, like how is understanding comes in. And people probably thought I'm crazy. A 7th grade, how do they understand? My son understand it. Other kids understand it. My son's not smart. Trust me. He's. Sometimes I want to strangle him. Well, I'm live streaming, so oh well. Yeah, he's not smart. He's not even half as smart as you guys at that age. Like he think about he doesn't know anything about Roblox. So, but he was able to understand it. Okay. So sine squared theta plus cosine squared theta is equal to 1. But he's getting better. So I can divide by cosine squared theta, cosine squared theta, cosine squared theta. That's equal to 10 squared theta plus 1 equal to secant squared theta. And this becomes the two things here. That becomes a 3 Pythagorean identity that you should know. Questions? Now, for this 3 identity, right? One of those identity also used pretty often in this format. When you're trying to proving identity, this one is basically, it's gonna say sine squared theta is equal to 1 minus cosine squared theta. You're gonna use this all the time. So don't forget that this is a variation of part A. So it'll be 1 minus sine squared theta. And yeah. So just understand that sometimes you're gonna see 1 minus cosine squared theta. You're gonna say, oh, that's sine squared. Or 1 minus sine squared, that's cosine squared. Just those are deviation. Actually, you can use different square to factor that again. You can say that's 1 minus cosine theta, 1 plus cosine theta, or 1 minus sine theta, 1 plus sine theta. So that's just a extension of a identities. But it's not an actual identity. That's an extension of identity. Now, for sum and difference, a lot of people have a hard time memorize that. Remember, 2 acronym is SMS and the CSO. So those are the first and second. So we're gonna start with SMS. I'm start with the S. That means the sign. Sorry, let me go back. I'll color code this. Can you guys see or no? Okay, sign, mixed group, and same sign. Okay, so SMS stand for that. So I'm going to show you how to do it. Sine is going to be sine, cosine, and then cosine, sine. That's how you mix group, because sine and cosine is a mixed group, not sine, sine, cosine, cosine. It's sine, cosine, cosine, sine. But order has changed too, because all I got to do is change it to A, B, A, B, and this is going to be plus. And that's the first identity. So the same sign, you start with plus sign, you just end it with a plus sign. Does that make sense? Am I going too fast, or you think you're okay? Yes. And don't afraid to ask questions. Jordan, do you understand? You sure? All right. Gabiola? Good. Okay. So the same thing is this part is gonna be sine, cosine, cosine, sine. A, B, A, B. The only thing is difference in minus sign, because it start with a negative sign, end up with a negative sign. Now, what does CSO stand for? C. The CSO, C stands for cosine. This is the same group. And this is the opposite sign. Does that make sense? So same group, do I start with cosine or sine? Well, it starts with cosine because the function is cosine, double sum and difference. So it'll be cosine, cosine, sine, sine, and then all I gotta do is exert A, B, sorry, this is A, B, A, B minus, because start with plus, end up with minus. You should be able to do the last one. I'll let you do the last one. Just basically follow pattern. What do you think the last one's going to be? Right. So right here is going to be cosine, cosine, sine, sine, and that's going to be A, B, A, B. Don't get confused with sine. Sine is going to be from minus to become positive. Now let's talk about the last one, double angle identity. Joshua says, Kench never talked about double angle identity. He probably did, just probably don't remember it. It's one of the things that's probably going to be first to forget is the identities. because they are just memorization. But instead of memorization, I want you to understand them. So what we're gonna do, we're gonna use prior identity. So you see that sign of a plus b right here? So instead of sign of a plus b, I'm gonna say, hey, what if I have sign of data plus data? Would that be sign of 2 data? So sign of 2 data, right? But sign of data and data, I'll just use the sum and difference. So again, SM, so it'll be sine, cosine, and then cosine, sine, right? And I'll put data, 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 plus. Now, sine, cosine, cosine, sine, this can switch order because they're multiplication. So what do you think the sine of 2 data is? Yes. 2 sine data, cosine data. Don't forget the data. Data is argument. Like if you do it, just write down 2 sine cosine. Yeah, it is a way, but if you write sine without argument, people don't think if you know the math. So you have to understand that argument is very important. Okay. Now, what will be cosine of 2 data? What do you think cosine 2 data is? Kind of close, but it's not. Alejandra? Why?
If you write it like that, it's gonna be data plus data.
Mhm.
So if you put it out with previous identities, cosine data times cosine data, cosine data squared. And then you just subtract.
Yep. Does that make sense? So it'll be cosine square data minus sine square data. So you just come out with the first double angle identity for cosine of 2 data. Now, some people last year when they take a test, they always don't write smaller or write it bigger. So this 2 is 2 data. They are same size. This 2 is the exponent. So make sure you, because some people write down as cosine 2 data minus sine 2 data, but it's not. It's actually cosine square data minus sine square data. So don't miswrite them. There's more, there's exponent, there's a coefficient. So you gotta make sure of that. Now there's 2 more equal sign. What does that mean? They have 2 other versions of it. So we know this is the official version right here. We're gonna use this version to convert the other 2. Now remember I say this is very useful, right? So then what we're gonna do is we just change the cosine. So I'm just only change the cosine. So change the cosine, and that's gonna be 1 minus sine squared theta minus sine squared theta. Does that make sense? It will be 1 minus 2 sine squared theta. It come out of double angle identity for the other one. Pretty straightforward. Joshua, give me a look like I don't know what the hell you're talking about. I just basically changed the cosine to 1 minus sine using this identity right here. And then that's going to be replace the cosine squared theta as 1 minus sine squared theta. And then minus sine squared theta is going to be 1 minus sine 2 sine squared theta. Too fast? Okay, I'm gonna go to the next one. So instead of replacing this, I'm gonna replace this part for this one. So I'm gonna write out again. So I'm just gonna be write out right here. I can say cosine squared theta minus Now, instead of sine squared theta, I'm going to change to what? Right? Now, be careful this distributing. So that's actually to end up to be 2 cosine squared theta minus 1. So it'll be 2 cosine squared theta minus 1. So this equal to cosine 2 theta. And this equal to cosine 2 theta. So this, sorry, this one, my bad. This one's going to be like this. And this is the first one. So there are 3 versions of it. Just basically change that cosine squared and sine squared to 1 minus sine squared or 1 minus cosine squared. Now, a lot of you guys will end up to go to VC Calc. Probably 6 of you guys will go to VC Calc. And if you go to VC Calc, then you're going to have to know what's power reducing. What is power reducing? Well, power reducing basically just, I'm going to look at this 2 formula right here or here. Why? Because imagine that you can use the second degree function to express the first degree function. And this is the only time can be done. Like say, can you express x squared in terms of lines? It's almost impossible. But for trig, it's possible. For trig is, if you take this, so 1 minus 2 sine squared theta equal to cosine 2 theta. And if I just solve for this, if I just solve for sine squared, which is, that's a power reducing. So therefore, I can move this to the other side. So be 1 equal to cosine 2 theta plus 2 sine squared theta. And again, I'm solving for this, right? So I move this to the other side. So be 1 minus cosine 2 theta equal to 2 sine squared theta. And then I'll divide it by 2. And I'll divide it by 2. That becomes 1 minus cosine 2 theta over 2. I derive it. Because for the next one, 2 cosine squared theta minus 1 equal to cosine 2 theta. This one, I'm just going to solve for this. So be 2 cosine squared theta equal to 1 plus cosine 2 theta. Now divide by 2 on both sides. So be 1 plus cosine of 2 theta over 2. Not square. Some people write down square. This is actually 2. And there you go. You know all the formula you can need for A, B, and B, C. We're only going to spend 3 days on trig. You have to know all your trig information by 3 days. And this is the first part of information. That's all the identities. Yes. Sure. I use a double angle identity to find out what the sine square and cosine square is. If you don't know how to do it, I think this, if you don't know how to do it, just go back to watch a video. Everything is up here. How much time I have? 10 minutes? Huh?
8 minutes.
Okay, good. We can go do radians. Unit circles. We should know all the degrees by now. I'm not gonna go over degrees, so but this is 0, 180, 360, and this is a. I'm sorry, let me redo that again. I'm gonna use black. This is a 0 degree. This is a 180 degrees. This is 360 degrees. This is 90 degrees. This is 270 degrees. I'm gonna color code this. If you have different color, use a color code because I want you to relate the 45, 135, 225, and the 315. I want you to color code this because all those that have the same reference angle. If you guys don't know what's reference angle is the angle from between the terminal side to the closest x-axis. And I'm going to draw it for you to show you in a second. Now this is 30 degrees. This is, what's the other side? What do you think this is? Huh? 150. But this is our reference angle of 30 degrees if you pay attention. This is 150. This is 210. This is 330. Now all this angle has exactly the same reference angle because they are formed with the closest x-axis. This is exactly 30 degrees. 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 So it's kind of like a butterfly. So that's why they have the same x and y values. It's just different sign. Now let's go to a different questions. Let's go green. Green is going to be 60 here, 120, 240, and 300. Now I have a color code all the degrees. I'm going to color code all the radians. Now, there's a specific way I want you to orient this because rest of them is actually pretty easy. I'm going to start with the black here. This is going to be 0. The 180 degrees pi, 360 degrees also 2 pi. There's another notation besides pi. There's another notation called tau. Tau is represents 2 pi. Nobody ever teach that. If you math competition, you should know tau is actually represent 2 pi. So here it's going to be pi over 2 because that's pi divided by 2 because from here to here is all the way pi, right? Now halfway has to be pi over 2. Now what happened in pi here? I want to write down something kind of important. Pi, I'm going to use the marker here. So pi represents 2 pi over 2, represents 3 pi over 3, represents 4 pi over 4, represents 6 pi over 6. So because 2 over 2 is 1, 3 over 3 is 1, 4 over 4 is 1. So that makes really easy to figure out this is actually just adding additional pi over 3, so it's 3 pi over 3. So 3 pi over 3. I'm sorry, 3 pi over 2, sorry. 3 pi over 2. 3 pi over 2. Okay, use that as a leverage. Pi is on this side, use that as a leverage. I'm going to show you how to work. So this one's going to be pi over 4. And this is going to be, what do you think this is? 3 pi over 4. Why? Because 4 pi over 4 go back. It's actually same angle, reference angle. So that you're going to use that as that. So that's going to be 3 pi over 4. And what's this? 5 pi over 4 because you're just adding pi over 4 to 4 pi over 4. And of course, this 2 pi you can write down as equal to, I don't know, is equal to 4 pi over 2 equal to 4 pi over 2 equal to 6 pi over 3, 8 pi over 4, or 12 pi over 6. I always think of it in terms like that. It's going to help you somewhere in the long run. So this one is going to be 7 pi over 4. Is that okay? Now I'm going to go to 30 degrees. How many of you guys know what's 30 degrees? Charlotte? Charlotte? 5 over 6. So that's going to be pi over 6, right? But what will be here though? Raise your hand if you didn't know. Yes. So I don't want to ask Alpha. Nicole? 5 pi over 6, good. This is 5 pi over 6. Why? Because it's subtracted from 6 pi over 6. Understand that it's a relationship to the 6 pi over 6. Now, it's a relation to this, the 7 pi over 6. And what will be this part here? 11 pi over 6. Wait, are you Charlotte too? Are those two Charlotte? Now we're gonna go to pi over 3. Pi over 3 is gonna be green, so pi over 3 here. 2 pi over 3. 4 pi over 3. And 5 pi over 3. Now the reason why I color code is because they all have same reference angle. Those of you guys don't remember reference angle, 5 pi over 6. Reference to the angle of 5 pi over 6 is pi over 6. How much time I have?
15 seconds.
Can't just accept it. No, I'm just kidding. No. I actually can teach in 15 seconds. Some people knows me. I can teach things in 15 seconds. Sure. What do you mean? You don't need edit. Some people want to edit.
Yeah, but on Wednesdays and Fridays I come from the tutoring. Okay, I saw that really
I cannot help you, but you can say please. Which class before you take? Last year, what did you take? Break out, or break out. What did you get at least for? Then you probably can handle it. So you are more like it's not incapable. It's not, you don't want. That's fine. I don't know. I have no control of it. But while you're here, you make sure you learn it. Hold on. Ready packet? Ready, ready. You do the packet? Yes. And the possible method. Use a little bit. You want me to hold it? No, it's okay. Put a trash can over there. Other people can walk in and then take away the trash can. Oh, morning, go to school. Oh yeah, maybe. Video? Like video at home. Some people watch. No one I do. Because it's school block. Because also the sunlight get on me. Because they have a field in school to the east. And so that's all. Exactly.
The packet?
Trick packets.
Someone's like 5 pages worth of packet.
Yeah. Did you do tutoring out in our school yesterday? The whole, yeah.
I did, but no, not a lot of people do.
Yeah.
Wow, you are really dedicated.
What are you doing today? What?
Oh, yeah. Why?
I was just talking for you left me basically.
There's a bunch of calculus papers on my desk. I don't think that should be someplace a student can get.
They already took it.
Right?
What do I say?
Who are you?
Oh, Fabian.
Are you from this school? Last year?
Yep.
What did you switch for? I didn't have it here before.
I just got switched to the class because I did pick up over summer. And I didn't
Break out in the summer. I don't think it's a good idea to take this class. I'm gonna be honest with you. Huh?
I've got partner.
Oh, you have a test then. So you have a test first day.
Even notice? What is that?
So
Oh, do I need to get a path to guidance, please?
I don't think that you have to show the form.
I did online, but they said to get a pass and come back.
Yeah, sure. Have a seat here. No, I'll give you a pass. Well, I'll give you a pass. Who says that?
I don't know, the lady there. I went like 15 periods to see, and she was like, go to class and get a pass and come back.
Give me a second. Have a seat first. Oh.
I had a Dr. Pepper instead of a Celsius.
Good for you.
I know, right?
I don't think Celsius is good for you.
It's not, but I don't drink it.
It's so bad.
I don't drink it much anymore.
My hand is like shaking every
I'm
time I drink.
limited to one per week.
Just because you buy a whole box, I never drink it.
Oh my god. I'm worried about the street.
All right.
Is that open?
All right. So I want to talk to you a couple things. So first of all, let's check attendance first because I forgot to check attendance last period. Let me. So let me see. Is everybody here? Isaiah is here. Who's it? Isaiah. Isaiah's not here. Isaiah Rivera. Not here. Okay. Naring, Brian, Yolanda, Vito, Fabian, first day enter. Okay. Fabian, you're 10th grade. Yeah, 10th grade. I mean, depending on how you're doing there. Lee Cumberland, Christian, Chase. Chase is here. Okay, Owen. Is Owen here? Owen's not here. Huh?
I don't think he's been here once.
Really? Do you see him in school? use him in school. Harmon, Evelyn, Nathan, Lena, Madison, Lucas, Elsa, yeah. Clear? All right. So, I did not grade your test. And there's a reason why, because yeah, I'll have mentally breakdown if I see this. So, the test score is gonna be probably between 0 to all the way to like 70. Some people can probably break 70. I don't know who. I think probably Safa. Safa can do it. Neoli can do it. So I don't know what is it, but so instead of me grading it and have my weekend, I'm gonna have you guys, if you're interested about each credit, coming back after school, what I'm gonna do is I'm actually gonna go over the whole test with you, each question, how do I award points, how do I give you points, and I wanted to let you see like what's perspective of where I come from. Now, and hopefully you understand everything, and hopefully you can grade a couple paper. I used to pay Anthony to grade, but I cannot afford Anthony.
How much per child?
So I used to pay Anthony, so I can't afford Anthony. I'm to be honest with you.
Like 5 cents per test.
If you have 2 kids and you have all the things you have to pay for, a box of chicken nuggets like freaking $20. So I just can't afford paying $80. But I appreciate Anthony though. So with that being said, what is the score that you should say here? There's some people I already talked to, like I don't think you should be here yet, and doesn't make it bad. Okay, so some people I would say it's this. I think I talked to a couple yesterday, but doesn't mean it's horrible because a lot of time you don't need to be. Like I will say that again. You know, you don't need calculus to be successful in life. Period. Actually, you know, calculus probably more likely you're not gonna be very successful. If you become a lawyer, you're probably more successful. Medical school, probably more successful. Probably a lot of situation, business person, politician. There's a lot of choices. Psychologist major, nursing, whatever. I can name like 20 professions that doesn't need calculus, and you're gonna become more successful than I am because I only get paid $55,000 a year, very minimal compared to. That's why I cannot afford anything. If I could pay 100,000, yes, Anthony, you can grade all my paper. So I'll be like, here's $100, here's $200, grade it, and I can move on with my life, right? Things like that. Some people it's gonna do bad, some people it's gonna do good. So what will be the things that you should decide to switch out of my class? If you score less than 40 without extra credit, consider it. Okay. If you score less than 20, then you should really say, maybe that's not my thing. But I don't see too many except few of you guys, probably 3 or 5. This class is not supposed to be this big. It should be around 20 students. Last year, every class got 20 students, 18 students. That's probably most optimized. For me, I look at optimization because I understand calculus is what's most efficient for everybody to pass at the same time. Right now, some people doesn't belong here. It doesn't help you or me. Because once you hurt your confidence in math, you're not getting back. I have seen people in the past, once their confidence shattered, then they are never going to come back. You'll forever hate math. And I'd rather you not. I'll give you an example. Anthony, I don't remember his last name, but Anthony, a few years ago, taking my pre-calc class. He was, he finished my pre-calc with a C. come up to me, Mr. Should I take AP calculus? I said, Anthony, it's okay. Take your time to do it right. So he didn't take AP pre-calculus. He back then there's no. So back then he he went to dual enrollment. He said, should I take a pre-calculus again? I said, no. Stop with algebra and then build your foundation back up again. So he did algebra 1 semester. So he's 10th grade. In the summer, he take algebra before he go to junior. Take it, and then first semester take pre-calc. Junior year. Second semester take Cap 1. Junior year. So by the end of the junior, he's already equal to all the people that would take an AP calculus. By senior year, he take Cap 3 in differential equation. So, Cap 2 in differential equation. So he's actually finished one semester. Everybody will finish BC. So in a way, I think for him was great because he come back, he's like, I'm doing total integration, I'm doing all this cool stuff. Now I remember like the day I was looking at him, I was like, oh wow, that's really drastic improvement. But the thing is, I didn't shatter his confidence. It takes his time. So the confidence is probably the most important part of math. Once I shatter it, you will forever hate math. You will never ever have a possibility to choose math again. Now, if I said take your time, doesn't mean anything to degrading you, not in any sort of way. You just take your time to get better at it. And that's gonna be a long advice to you. It's nothing wrong. With that being said, I'm still offering 10-point extra credit for you to come in, but it's more like test correction because I will actually ask you to stay a long time. I'm gonna go over each questions. And you're gonna say, okay, which part I understand, and then you can grade a couple of papers for me. Everybody grade a paper, then that paper stuff. So that way it's helping you, helping me. You got it. I don't hurt myself. I'm here pretty much every day. I want to help you. Yesterday was gas leak. I'm still here. Not many people show up. I'm here. Throughout the year, I show up almost all the Saturdays for April because I want student to pass. I'm not a better teacher than a teacher. I just work very hard because I choose to work hard because I'm very competitive. So far as the unit circle goes, Andrew, can you pass out that paper in the back? Everybody's. Now, please don't start with write down unit circle. I know how excited you see unit circle. You want to start writing on it. But the thing is, I want you to understand things before we start. It's just because this. So we are not gonna do Monday for trig test. We're gonna do Tuesday because yesterday has a gas leak, and we had to find a way to catch up the period.